I have started recording this. Okay, hardware skill. I wanted to know your hardware skill. So that is why I have started to take this session so that you will have good understanding on the hardware part. Apart from this, what are the basic that you have on the hardware level? Basic level of knowledge. Let me put it here full page. Okay. So today what we will cover, I will cover most of the hardware part. Then I will jump into the Linux part. Once I am done with the hardware part, we will be focusing on the hardware, much on the hardware. So let me put this as 120, 170. That's the mean. So you guys tell me what is your level of understanding of the topic. Okay. So I will give you how you are going to rate me. Okay. I will show you whenever you start any course. Okay. What is the course level? I don't have here. So 101 is basic. 201 will be your intermediate, 301 will be advanced. Which level you are? This is basic, okay. 201 is you know little bit and you are in intermediate, okay. So 301 will be advanced stage. Okay. So I want everyone to tell me their level in hardware so that I will know my audience.
So not once, it's easy to understand a little bit.
Okay.
So just based on the practice.
Okay, no problem. You, Joy, how about your knowledge on this hardware part?
Hardware part, actually, I have most of the hardware part I have
301 you want to say?
Yeah.
Okay. Chandana, how about you? No, do you have basic knowledge 101, 201 intermediate or 301 advanced? You know most of the things. Which one, which is your level? Yeah, hardware skills.
I don't have any idea.
Okay, most of them are in basic level. Okay. So let's start with motherboard. Okay, main circuit board, or we call it as motherboard. That you will have CPU, RAM, storage, and other peripherals. You will be connecting to that. Also, these are all the different types of motherboards. You have a server board, motherboard. These are all other types. Okay. You have ATX, micro ATX, mini ATX. I will be covering these three only. Okay. I will not be covering other one, so that you will get an understanding of that. Okay. So what does in motherboard you will see? Most of the parts, it will be like your CPU. This is called a CPU socket. Okay. And you will have a cooling fan for this. Okay. And you will have a heat sink. Okay. All the heat it will throw away here. Okay. This will be your heat sink. And you have RAM slots here. 1, 2, 3, 4. So in these slots you will be keeping your RAM, and this is your 24 pin ATX power. This is where the motherboard is getting the power. And you have here this is your NVMe hard disk. Okay, I will show you in the institute. We have one computer which has this NVMe, okay, slot, and this is called a chipset. We'll see what is that all we'll be doing.
Are you sharing your screen or no?
Am I sharing my screen or not? Sorry guys, I didn't share it.
So your screen is not visible because it's a blind one. Yeah.
Let me share from beginning. Okay. Okay. This is what I was talking about. Okay. Let me zoom it a little further. 170. Okay. This much. Okay. This will be fine. I will be repeating this again. Okay. These are all the types of motherboards. We are not talking. We are not going in detail about this. You just have to picture this in mind. This is how it will look. Okay. So you have here. You will see all these things. Okay. So later we will come back here. Okay. Once we are done, we will come back. You will know what those are. Okay. So I will be covering this micro ATX, ATX, and mini ITX. Okay. These are the boards. Okay. So this is having a huge RAM, huge 250 MB file. Okay. So I will reduce this. Okay. This is what you will have in computers. You will have, this is your CPU socket. Okay. And then this will be your cooling fan. Okay. So where all your heat will be exhausted. Okay. So here one main part is the air should go out. Okay. You ensure that the air is going out. It is not pulling from the outside. Okay. So all your hot air should go out. And here you will have heat sink. Okay. So here 8 pin, this will be powering your this part of the area. Okay. This will be your main part where you will get the power, 24 pin ATX power. Okay. This is like your main motherboard main. Okay. And you have hard drive here, NVMe hard drive. Okay. And you have the chipset. We will see what the chipset will be doing here. Okay. The motherboard chipset, we call this as chipset. Okay. And you have SATA connector. You will have connecting to your hard drive, all that. Okay. So then you are powering up with the PSU, power supply unit. So wherever you want, you will be supplying that power. So we'll see that PSU also in details. Okay. Today we'll see what and all you can have it here. Okay. Then you will have PCI slots. Okay. Where you will have an extension slots. Okay. And you will have graphics GPU, where you will be processing your graphic cards. Backside you will have all your input, output, everything you are going to connect. Okay. So we'll see that one by one. Okay. So let's say I am just connected one of the parts. Okay. So this is your motherboard. Okay. And then you have your PSU, power supply unit, and then you have here graphic cards. You have just detached it, and then your memory, RAM, and these are your CPU coolers. Okay. So you will be exhausting out the fan. You will be cooling the server. Okay. If you are not cooling it, once it reaches 100 degrees, it will automatically turn off. That is why cooling is very important. So all the AI data centers, where whatever query you are doing it on your chat GPT, it will take at least 1 liter of water. So your chat GPT, if you are querying it, you are consuming 1 liter. Okay. Now you have motherboard side. This is what I told you about. ATX. This will have most expansion slots here. Okay. You see it here, one, you can put one graphic card, other graphic cards, or else you can put multiple extensions. Okay, that is where your ATX will come. If you want to have multiple additional devices, you will go with the ATX motherboard. Okay, this will be best for performance. And if you want to upgrade, like you want to upgrade your PC, then you will go ahead with the ATX, and this will be having a bigger size. Motherboard will have bigger size, and typically will have 4 RAM slots. RAM you can put 4 number here, whether 8 into 4 GB or 64 into 4 GB or 2 into 4 GB, 2 into 4. So you can take any number of.
ATX different and ATS is different, sir.
Sorry?
ATX and ATS.
Yeah.
Both the things different because I remembered a similar word when our resumes get shortlisted in any of the companies. Okay, so I guess that will be based on the ATX or ATS.
Which one you are talking?
Keywords.
Which one you are talking about?
No. You told us ATX, no? So I just remembered a similar word, something called as ATS or something. I don't remember that. When we upload our resumes in any of the companies, so they shortlist the resumes, right?
So that is different.
ATS friendly or ATX friendly?
That is different thing. So we are talking about the complete hardware here.
Got it.
Hardware part. That is different. We'll see that later. Okay. Now you have micro ATX. Micro ATX will be, you want to have a high-end gaming server, gaming system. Then you will go ahead with the ATX, micro ATX, which will be compact. Okay, and it will fit in ATX cabinet or mini ATX cabinet. Okay, and you have mini ITX. This will be very small. Okay, so you want just to run. Okay, or you want to run a YouTube channel. You don't want any graphical. That's it. Okay, this will be smallest. You want very compact. So that is where the motherboards comes. Okay, so typically I am covering 3 here, 3 motherboards. Okay, so what you are talking about, that is ATS. Okay, that is a tracking system, applicant tracking system. This is not. This is ATX.
What is?
Now you have how you are going to choose the processor. Okay. So let's say whether you want to go with the AMD or Intel. So who is having AMD here in this group? AMD or Intel? Hmm? Yeah, I heard. Chandana, how about you? And who else? 2, 3. Intel. Pranav, your laptop is also Intel, right?
Right, so yes, Windows.
See, my server is AMD. Okay. So why I choose AMD is third factor, affordability. So if you are on a tighter budget, okay, you will go ahead with AMD. If one is your prime factor, you will select, okay, if your main focus is on gaming, you will pick it up AMD. If your aim is for multitasking and productivity, you will go for Intel. Okay, so you will have overclocking here. Okay, we will see what is overclocking. Okay, so it will be power efficient Intel. This will consume lot of power AMD, and you will have more cores here, higher number of cores in AMD, and it is good in managing the heat, thermal heat. Okay. So this will get heated very faster for laptops, but servers it will work very fine. Okay. Now you have Ryzen 5 and Intel i5. Which one is better? So these are just basics. Okay. Like it is excellent for multitasking, or you want to create a content. So this will be all with respect to graphics. If you are working with graphics, then nobody will beat AMD. Okay. Other than graphics, you want to work on something else, it will be Intel. As simple as that. So if you put heavy load, it will run cooler. Okay. On thin laptops, it will be very hotter. Intel i5. Okay. So this is your difference between Ryzen 5 and Intel. So AMD family types. Okay. So this one you will have S type, which will be higher. Okay. And if you want A type, second class, then you will have AMD Ryzen 7 and Intel Core i9. Okay. Core i9 will be at the third level. Fourth, it will be i5, Core i5. It is okay. So if you are on budget, low budget, then it will be Ryzen 5. So this is how you are going to select. If you are peak on the gaming, then you will go ahead with this type of processor. Now you have something called as types of core. Okay, single core, dual core, quad core, hexa core, octa core, DC core. So it depends on how your processor is capable of doing that. So what is the use of cores here, Joy? Yeah. So what is the use of cores?
Use of course means we can process multiple operations in same.
Okay. And any other guys who can answer that? So how many cores you have? You also share your screens so that I will know what exactly you are following up. So Chandana, how many cores you have on your laptop? You just open Task Manager, okay? Task Manager, okay? Then once you open Task Manager, you click on Performance. There you will see your cores, okay? I have four cores. 8 logical processors.
Uh,
Okay. How many cores you have? One CPU socket. Okay. 8 logical processor I have. Virtualization is enabled. L1 cache, L2 cache, L3 cache. Okay. We'll see what those are. Okay. You have process, threads, handles. Okay. So utilization and speed you have it. Okay. So I have one graphic card here, GPU, NVIDIA GeForce GT730. Okay. You see, I have connected 3 Ethernets here. 1, 2, 3. One is operational, that's it. The other 2 are, they are not working. These are the physical. I connected through wireless. Okay. Now you tell me how many cores you have on your CPU? Okay. 2 cores. How about you, Chandana?
four courses.
And your memory speed?
Memory speed, like 8.4, 15.3 GB.
Okay. Base speed. Okay. Click on memory. Okay. Click on memory. See, you are having 550 million transaction per second, MT by S. Okay. Megahertz. So it is very speed. For you, cached is 7.0. Let me share my screen. Yeah, Pranav, you share your screen. So you are having latest laptop. Okay. Click on the CPU.
Sir, I am logged
Huh?
in with my mobile, not with the laptop today. I am logged in with my mobile, not with the laptop today.
Okay.
Just sometime.
Okay.
Actually, there is no power because of which I am logged in with my phone.
Okay.
As soon as we connect up, I log in with the
Okay, okay, no problem. And you have, Chandana, 2 of your 2 slots you have used. Here, down, yeah. Slots used 2 of 2. Okay.
Yes, sir.
Form factor other. Hardware reserved 736 MB. You have paged pool, non-paged pool. We will see all this. What is that? Okay. You click on CPU. Okay. You have base speed 2.8. You have one socket, 4 core, logically 8. You have L1 cache, L2 cache and L3 cache. Okay. You have 259 processors, 411, 4100 threads and handles. Click on the GPU now. Down, last. Down. So now you have here PCI bus 3, device 0, function 0 in the bottom. Okay. So you have driver version, you have dedicated memory, all that. Okay. And you are getting 60 degrees centigrade temperature. Okay. So I will take it over. Okay. So now let me show my screen. Okay. CPU. You see my CPU 3.5 gigahertz. L1 cache, L2 cache, L3 cache, and then memory 800 megahertz. See how low it is, how much speed. So you have a very good speed. Okay. So my speed is very limited. So I have used only 3 of 4. Form factor DIMM. Hardware reserved is 50 MB. Okay. So we'll see what exactly that is. And my complete memory is 24 GB DDR3 RAM. Okay. So your RAM is DDR5. Can you show me again, please? You share your screen. What is your memory type? DDR3, 4 or 5? what is CPU, GPU, TPU and MPU? Yeah, Joy. CPU, we know, everyone knows CPU. I don't want to discuss on that. GPU and TPU, NPU.
GPU for related to graphics.
Okay. Why can't you run on CPU graphics?
Graphics, I don't know the proper answer why, but graphical capabilities only supported by GPU.
Okay. See, whenever you do rendering, okay, you will offload it from CPU and it will go to GPU. Okay, it will be mostly on the parallel processing. Okay, like whenever you have a content, you need to have a graphical processing. You will have a GPU. Okay, so let's say you want to do some Bitcoin stuff.
Okay.
Uh, you will have some different device. Okay. Bitcoin miner machine. Okay. So this is a Bitcoin miner. Okay. So this will have a different algorithm to run. Okay. If you run in CPU, the logic, it will run 100 times or 1000 times faster than a CPU. This machine. Okay. So if you are running on a GPU, one second guys, I am taking call. Hello. Anyway. Okay guys, sorry. So in this form, okay, you will be mining it with these type of devices. On CPU you cannot run. You will have a lot of farms. Okay. You see these are all Bitcoin farms. If you see that, these are all devices that they are running that hashing. I will tell you what is hashing also. So you with CPU you cannot achieve this much. Okay. You see here how big this farm is. So I will take one more here. I have all these farms. See. So you will have a GPU cards or those mining device where they will run all the operations like that. Okay. This is all your Bitcoin farms where they will be mining that Bitcoin. Okay. So that will have a different processing. In CPU you cannot do that processing there. Okay. So similarly you have a tensor processing unit, okay, which will train you on the AI part. So we'll see that one also, what is that TPU is. Okay. TPU processor. how it looks. GPU on TPU. So this will be for your AI. Okay, you see CPU, and then GPU, and then your TPU. Okay. You want, you can go in details what these are exactly. You will have those videos in YouTube. Okay. If I go ahead, then it will take a lot of time. Okay, I don't want to go inside that. So I will just give you an overview of that. This is how they look. Okay. So this one will cost you around 1.2 lakhs high end. CPU, it will be mostly from 4,000 to 30,000 you can buy. I don't know about TPU. Okay. So this is how you have all your devices, NPU. So Bitcoin farm I have not mentioned here, I have not added that. So you can add that one also. That is for pure mining the Bitcoin. Now we'll start ahead with the CPU. Okay. So what and all you will have in CPU? Chandana, this is for you, Usha. So you learned in degree, right? What all you will see in CPU? Yeah, Chandana. Come on. Okay. So you will have mainly you have three parts. Okay. One is your arithmetic and logical unit, ALU. Okay. Then you have control here, controlling the unit. Okay. And then you have memory and registers. Okay. Where exactly your memory is residing, from where you are coming, all that. So these are the main parts. Okay. What the CPU is doing. So what exactly the CPU does? Okay. So what CPU will be doing is, it is going to fetch the instruction. What exactly I have to do? Fetch is like you want to get instruction what to do. Okay. Then it will decode. So it will translate the commands. What I have to do? It will execute. Then once it translates, it will execute. Or it will write into memory, or it will read from the memory. This is what your CPU will be doing. Mainly 4 operations it will be doing, or 4 functions it will be doing. Okay. So how your CPU you are specifying? So you will be specifying with keys specification. Okay. How many cores you will have? Okay. How many threads it will handle? Okay. What is your cache? Fast local memory, L1, L2, L3 cache. What is that? We will see that. What is that? So what is your clock speed? What is your processor speed? So just now if you see, my processor is 3.4 gigahertz. It is running at that. My base speed is 3.5. Means my vehicle can run up to 350 kilometer speed. Okay. Now right now I am running 3.46 speed. So if you see, I have 8 core here. So I have threads, and then L1, L2, L3 cache. Okay. So which CPU do you need? Based on the cores, you will identify which one you want. Okay. So you want basic, 2 to 4 is fine for web and office. Okay. So for gaming and heavy usage, you will go with 6 and 8. Okay. If you are doing any video graphics or 3D or animation, you should go with the higher end, 8 plus core. This is how you will identify the CPU. So what is EFI? Joy. EFI. Joy? You only EFI.
EFI extensible firmware update, the latest firmware we are using, previously we are using BIOS legacy.
Okay.
So it's the interface between the hardware and the OS.
Hardware and OS.
Operating system OS.
Okay. No, not convinced yet. You can see the diagram and you can explain. So I will come back here once I do it, the booting process. After that I will come back here. Okay. So I will skip this part. Now you have a CPU pipeline and instruction. Inside CPU you will have cores here. How many cores? Let's say you have 8 core here. 4 and 4. Okay. Let's say you have 4 cores. Then you have instructions coming in. Okay. You have instruction on your pipeline. And you have arithmetic and logical unit. Okay. And then you are performing the operations and registers. Registers will see what exactly these are registers. So anyone knows about assembly language? In degree you might have heard the assembly language.
Assembly line.
Okay, no problem. Okay. So let's say you have a sequential execution. Okay, there is difference between sequential and parallel execution. So one example I have taken and I explain you with respect to square root T1, T2, T3, T4 like that. So you remember that Joy? Chandana? So here if you are having sequential execution, it will take step by step. Okay. If you have parallel execution, it will be multiple execution at a time. Okay. So this is how you will be executing. This depends on the settings. We'll see that one also, how that settings will work. So now you have ALU here. ALU work with the logic. Okay. Any arithmetic will be based on these 3 gates, and or not. So if you combine not and it will be NAND. Okay. So all your data whatever coming, arithmetic operation, all your arithmetic operation, it will be done through this gate. Okay. So I don't want to go into all these logical operations. This is how those gates will work, and then you will get the results in binary system. So through binary system again it will convert into human readable. So that is how our ALU will be working. Okay. Then you have TLP, thread level parallelism. Okay. So this is what I told you about the T1, T2, T3, T4, T5 like that. So Pranav, you remember that or you don't know about that? T1, T2, T3, T4, T5.
I remember, sir.
Yeah, this is how it will be. Parallelism, through parallelism it will be running by that processor. You see it here, threads. So these many threads are being run by this 183 processor. Okay. So let's say I will calculate how many threads are running per processor. Okay. Now I have 2438. Okay. 183. Okay. So each thread it is handling, each process it is handling 13 threads. It divided into 13 and it is running. Like one guy is running a horse, 13 horse at a time. He is not riding on a single cart. Okay. He has kept 14 horses and pulling his cart. Okay. Now I will see how much memory handles he is holding. 76337 divided by 2455. Okay. So one thread is handling 31 memory handles. Memory RAM that is holding positions. We'll see where this exactly will holding. Okay. So single thread execution it will be on the CPU core. Okay. Everything it will be running one as a one. Okay. Whereas if you enable thread level parallelism, you will be running it task 1, task 2, task 3 like that. Parallelism will be there. Okay. So you will use better CPU utilization. So you will use the better CPU, okay, but this will be slower. But this one will be faster. Utilization wise, you are utilizing the process here. So you can ask how come you said it will be faster. Now you are telling that this will be faster and this will be slower. You should have got a doubt, right? Single thread execution will be very faster, but you cannot utilize the CPU efficiently. There will be a CPU utilization low. Here you will have CPU utilization high, but processing will be little slower compared to single thread execution. You write down this, I will explain you in the class why I am telling this. Okay. So now you are enabling hyper threading here. If you have not enabled hyper threading, virtualization will not work on your laptop. If you want, you can disable that. If once you disable it, the hyper threading will not happen. It will be your logical processing will go. Only you will have a single CPU. It will come as a single CPU. You will not have a logical cores there. So this one will go. Okay. So this logical processor it will go. Okay, you will have only CPU socket and that cores. Okay, this will be for multitasking. It will be good for multitasking. This will be better for performance. Okay, so we need a better performance for virtualization. So if you want to run any batches or execution, then you will take this single threaded. Like you want to execute a program, you want to run a batch file, then you will go ahead with the single threading. Okay. So now you have x64 and x32 bit. So the difference between 32 bit and 64 bit is you will have a higher performance and longer memory addressing. So in 32 bit, most of the older hardware only will run. Everything will be 64 processor. Even if you are downloading any hardware, it should be 64-bit. So let's say if I want to download something, Fedora, okay, or any other operating system, I will go to distro watch. Now any which one? Ubuntu I will select. Ubuntu download. Okay, download Ubuntu. You just let me know. Are you bored or it is interesting or is it fast? How it is? I will stop recording.